Chapter 16, the Internet and Telecommunications. What is the Internet? The Internet is a global network of millions of individual networks. Individuals, businesses, universities, and government agencies link to the Internet through Internet service providers like Comcast and AT&T. Where is it? The Internet is global and has no central location. Networks around the world are linked together. What does it look like? This mesh of networks has links that create multiple paths to get from one point to another. The multiple paths provide redundancy should a portion of the network fail. Who owns it? The Internet was originally established by the U.S. government along with U.S. universities. It has since transitioned to private firms for support. Watch the video in optional readings, How the Internet Works in 5 minutes. We see the way devices are connected together. Each device has a unique IP address to facilitate routing of messages from the sender to the receiver. Dynamic name servers are used to convert user-friendly names that are translated to the appropriate IP address, which is then used to route the message. Now that you understand how the Internet works at a high level, let's review some of the details. A network provides communications, data exchange, and resource sharing. The network is created by linking two or more computers together. Resource sharing includes shared printers, data storage, and other devices. Telecommunication systems are used to link computers together. These systems send data over public or private networks. This can be completed via physical cables or wirelessly. Voice communication, like the classic telephone, is handled like another application on the system. VoIP, or Voice over Internet Protocol, takes sound and converts the analog signal into a digital stream of data, which is then sent over standard computer networks to its destination. There, the receiving computer converts the digital stream back into an analog signal, which, when fed to a speaker, recreates the sound of the sender's voice. The use of VoIP means that the wiring and associated systems of the traditional phone company are no longer needed where data networks exist. 3 types of networks are the most common. Local area networks, LAN, are found in your home and businesses and are generally limited to one building or site. Wide area networks, WAN, connect multiple sites that may be located around the globe. WANs are often used to tie together multiple local LANs. Finally, metropolitan area networks, MAN, are set up to handle data traffic near major cities and large universities. The architecture of a network defines how the devices are connected together. This reflects the logical connection or how data transmissions will behave on the network. There are 2 common types. Network topology, on the other hand, refers to the physical connection of the network devices. If you took the network devices and connections and laid them all out on the floor, the topology is what you would see. It is the arrangement of physical devices. There are 5 common types of topology and include the different pieces of hardware that tie all the networks together. Remember that data communications come in the form of binary strings of ones and zeros. Turning these strings into data is done through the use of protocols. These are agreed upon standards established by the Institute of Electrical and Electronic Engineers, or IEEE. These standards apply to all computer networks around the world. Without these standards, each device manufacturer might create their own standards. The result would be that 2 devices could not communicate unless purchased from the same company. Imagine if your iPhone could only talk to other iPhones. This would block global communication of voice and data. The next element, media, describes the physical cabling linking the various network pieces together. Media can come in the form of coaxial, twisted pair, and fiber optic cables. The simplest form of architecture is peer-to-peer, where individual computers are connected directly to each other. This approach is easy to implement but is not practical for large-scale networks. There is no good way to create a peer-to-peer connection with multiple machines. A common approach uses client-server architecture, where individual machines connect through a central network. With a simple client-server setup, a central file server controls access to resources, including file sharing, printers, and email. The next level includes N-tier client-server, where tiered servers provide access to central databases and web applications. The diagram on the left shows the setup for user access to a central database by using web access. The user interacts with the web browser on the left, which communicates with the web server. The web server then forwards requests for data to the application server. This server interacts with the database server, which uses a database management system, or DBMS, to access the data. The data is forwarded back up the chain to be presented to the user by the web browser. This architecture can be represented by the presentation tier, which interacts with the user, followed by the application server tier and the data tier. Note that the firewall provides security to control user access to the applications and data. Networks are designed using 5 common topologies. The first, the bus, uses a single common backbone that provides connectivity to all the devices on the network. The bus is relatively inexpensive and easy to install. The disadvantages of bus networks are that the whole network will collapse if the backbone is damaged. The network slows down if additional computers are connected. Finally, the limited length of the cable in any network may limit connectivity. If you have a central network device with each computer connected to it individually, you have a star topology. The advantages of a star topology are that it is easy to set up and configure and easy to detect errors once operational. Failure of a single computer or cable does not affect the entire network. The disadvantages include the amount of cable required, which may increase the costs, and the fact that the central network device poses a single point of failure. Devices in a ring network are connected to each other with messages passing from machine to machine in one direction. Each computer gets equal opportunity to access the network resources. Ring networks are not easy to set up and reconfigure. Another downside is that the failure of any cable or single device may infect the entire network. It is difficult to detect the errors in this type of network, plus adding or removing a device affects the entire network. Wireless networks use radio transmission to and from a receiver or transmitter. Wireless networks can be complex but can provide flexible coverage. Wireless networks are becoming more common. You probably have one at home and are using one now to access this video. This includes Wi-Fi and cellular data networks. Hybrid networks are simply combinations of the previous discussed network topologies. For example, my network at home is a hybrid of star and wireless topologies. What network topology are you using right now? These networks vary in advantages and cost depending upon the design and the setup. Hybrid networks are the most common. Network connection devices tie all the pieces together. Hubs are multi-port repeaters that copy inbound traffic and send it out to all connected devices. Hubs are not secure and can cause bandwidth issues. Switches are intelligent hubs and only send messages to the proper destination. Switches are more secure and limit bandwidth needs to only what is necessary. Routers connect segments of the network to each other to enable messages to travel from one network to another. Routers examine each message packet for its destination and forward them as appropriate. Routers may also convert messages from one media type to another, like fiber optic to copper cable. Wireless routers examine each packet for destination and have the ability to switch between media types. Wireless access points, or WAPs, are essentially a wireless switch. You are probably communicating digitally through a wireless access point right now. For most home and small office networks, a wireless access point provides wireless connectivity via Wi-Fi. The access point is physically connected to the local network. Protocols are used to manage the binary strings of ones and zeros and turn them into the digital functions like email, web browsing, and messaging we have come to expect. These international standards specify how data will be formatted along with the rules to be followed for transmission. While there are a number of transmission standards, the Ethernet has become the most accepted. Ethernet protocols really made the Internet possible for the majority of users. This protocol is easy to understand, manage, and maintain. It is inexpensive and flexible and guarantees connection. It does this through the TCP protocol. TCP stands for Transmission Control Protocol. TCP uses a handshake approach to send message packets and confirm their receipt. IP stands for Internet Protocol. They work together to create TCP/IP. These protocols manage addressing and routing information. This includes IP addresses. Examples include 192.168.1.1 and 10.0.12.45, which happen to be admin login addresses. Each device connected to the network has a unique IP address. While the technical details are fairly complex, models have been created to clarify how these protocols work together to facilitate data communications across the network. The two most widely used models are the Open Systems Interconnection or OSI 7-layer model and the TCP/IP 4-layer model. Here we see a comparison of these two models. Note that the user is at the top interacting with the application layer, for example using Google Chrome as a web browser. At the bottom, the physical layer connects with the actual network copper or fiber optic cabling. Each layer communicates with the layers above and below it, effectively translating the data for the use of the next layer. While the TCP/IP model has fewer layers, it incorporates the same functions as the OSI model. Regarding IP addresses, there are two primary addressing schemes in use today. The original format was IP version 4 or IPv4. IPv4 uses a dotted decimal notation. This is one you may be familiar with. Each address has 4 sections separated by dots or periods. Each section consists of 8 bits representing the decimals 0 to 255. Together they form a 32-bit address. Examples include 192.168.1.1 and 10.0.30.254. Each device connected to a network requires a unique IP address to make sure packets are delivered to the proper recipient. The problem is that the world is running out of IPv4 addresses. IPv6 has been added to address this and other issues. IPv6 uses a hexadecimal notation. Hexadecimal numbers include 16 characters each. A hexadecimal number starts with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. This approach creates much larger numbers. Each IPv6 address is made up of 8 sections instead of just 4. Each section contains 4 hexadecimal numbers for a total of 65,536 values per section. The result is a 128-bit address. Note that each section of an IPv6 address is separated by a colon instead of period. Examples of IPv6 addresses include 2001:db8, :85a3, :8a2e, :370:7334, and 2001:0db8, :85a3, :0042, :0000, :8a2e, :0370, :7334. Note that these are the same address, but with IPv6, leading zeros may be removed for clarification. Comparing the two TCP/IP addressing schemes, we see that IPv4 has over 4 billion public addresses. Even with all these addresses, the last addresses were allocated in February of 2011. No new address blocks are available. On the other hand, IPv6 has over 340 undecillion addresses available. That's 340 trillion. That's a lot of addresses. You may know that each of us uses multiple addresses. For example, your PC has a wired and a separate wireless address. Your smartphone and connected doorbell have addresses as well. At this time, there are roughly 7.8 billion people on the Earth. The IPv6 scheme allows each person with over 43,000 trillion addresses each. That should last us for a while. There are a number of applications available within the TCP/IP protocols. The File Transfer Protocol (FTP) is used to move files across the network from one device to another. It is easy to use, but not very secure. The Simple Mail Transfer Protocol (SMTP) is used to manage email traffic. Telnet is a simple text method used to communicate with remote devices. I'm sure you're familiar with Hypertext Transfer Protocol. HTTP makes your web browser user-friendly. This application really opened up the internet to the average user. SNMP is used by IT people to manage digital networks. Finally, Voice over Internet Protocol is used to send and receive phone calls over a digital network. VoIP has gone a long way to eliminate the traditional wired phone at home. Why run phone lines when you already have the internet connections? Vonage is an example of a VoIP-based service. Different physical media are used to make the necessary network connections. Options include twisted pair cables, which use 8 sets of twisted copper wires and may be shielded or unshielded. Twisted pair wiring is often used within building local area networks. Coaxial cable is common between locations and is often used for cable TV. Finally, fiber optic cables are used when covering great distances. Fiber optic provides top quality and security since it is not affected by electromagnetic interference. Wireless connectivity provides an alternative to physical connections. Wireless media includes Wi-Fi, which is commonly used by wireless access points at home and in small offices. WiMAX is a new standard for wide area coverage of up to 75 kilometers. Bluetooth is used to connect personal devices like earphones to smartphones. Broadband cellular, 3G, 4G, and now 5G, enables you to transfer data over your cellular network. Other applications of wireless media include wireless sensor networks and radio frequency identification tags. RFID is used to tag merchandise and scan it remotely. We communicate with satellites overhead using wireless communication. Microwave radio transmissions are used by businesses and government agencies to provide point-to-point communications from one location to another. Just a reminder that digital traffic is really a stream of ones and zeros. Recall from our previous discussion the definition of bits and bytes. A bit is a single binary digit, while a byte is made up of 8 bits. When discussing network performance and capability, we talk in terms of bits and bytes. Data storage is measured in bytes, like gigabytes. The larger the number, the greater the cost to store and manage the data. At the same time, we are concerned with how long it takes our data to go from one point to another. This is the data transmission rate and is measured in bits per second, or BPS. We use the same prefixes and think of speeds of transmission on the order of megabits per second for wired Ethernet networks. This is a rather complex topic. To summarize and hopefully clarify the concepts, take a look at the Warriors of the Net video. The link is found in Blackboard. This concludes our discussion on the Internet and telecommunications. Next, we will discuss information security.